Hello, welcome. In the view of the forthcoming JAMB 2025, we are going to be looking at questions we are likely going to expect, or the questions we are going to see in the forthcoming exam on machines. Let's dive into it. A machine whose efficiency is 60% has a velocity ratio of 5. If a force of 500 Newton is applied to lift a load of P, what is the magnitude of P? Now, in this question, one thing that will come to our mind is this, the parameters given in this question, okay? Now, in the parameters given in this question, we are given the efficiency to be 60%, okay? Now, this particular machine has a velocity ratio of 5. So, we should also take note of that the velocity ratio of this machine is 5, okay? Now, if a force of 500 Newton is applied, now, which force are we talking about? The force that we apply to a machine is certainly our effort, okay? We are going to apply our effort on the machine. So, the effort given in this question is 500 Newton. Okay, now to lift a load of P, what is the magnitude of P? Now, what you're looking for is what? Is the force, which is called the load. You're looking for the value of the load in this question. And the options provided, option A is 750 Newton, option B, 4,166 Newton, option C, 500 Newton, and option D, 1,500 Newton. So the first thing we are going to do is to state our parameters given. After that, we are going to look at the most likely formula that we are going to use to solve this particular problem. So let's go. Efficiency is equals 60%. Now the velocity ratio is equals to 5. Our effort is given as 500 Newton, okay? And we are looking for the magnitude of what? P. P happens to be our what? Our load. Alright, so the first thing we are going to do is to state our efficiency formula, which is efficiency is equals to mechanical advantage over velocity ratio multiplied by 100%, okay? And don't forget that efficiency is expressed as a percentage. Alright, so we have 60. Remember, because we have multiplied by 100% here, we just leave it as 60 here without saying 60 over 100. Please don't forget that. We say 60 over 1 is equals to, because you're looking for the load, and load is embedded or load is gotten from mechanical advantage. So the first thing to do is to get a mechanical advantage. So let's make it the subject of the formula. I have MA divided by 5, because my velocity ratio is equals to 5, then multiply by 100%. Alright, so the next thing you are going to do is to say that 60 over 1 is equals to, now this 100% should be over 1. That means we should remove the percentage. 100 multiplied by MA is going to give me 100 MA. Alright, okay, divided by 5 multiplied by 1 is going to give me what? 5. Alright, so let's proceed. We are going to do now cross multiply. We do cross multiply. 100 MA multiplied by 1 is going to give me 100 MA. Alright, then it's equal to 60 multiplied by 5 is going to give me 300. Okay, that is 300. So let's divide both sides by the coefficient of MA, which is 100. I divide. Okay, this cancels this. Now my MA is equals to 3, right? Now we should not forget that mechanical advantage is equals to load to the effort. Now MA is equals to load to the effort. Okay? Alright. Now let's substitute our value. My MA is equals to 3. Then is equals to, what's my load? That's what I'm looking for. It is called what? P. So what is my effort? My effort is what? 500. So I'll say 500. Alright. So what do I do next? I'm going to do cross multiply. Now this is over 1 cross what? Multiply, right? So let's go. P multiplied by 1 is going to give me what? P. Alright. 3 multiplied by 500 is going to give me 1500 newtons, because load is a force. All right, so from what we have solved so far, the correct option to this particular question is option D. I hope that is clear. Let's look at this question. If a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, its velocity ratio will be what? Let me go to again. If a heavy barrel is rolled up a plane inclined at 30 degrees to the horizontal, its velocity ratio will be what? The options provided, we have option A to be 3.0, option B to be 3.1, option C to be 3.2, and option D to be 2.0. All right, so the first thing that will come to our mind is this type of machine that we're going to use to raise or to pull up this heavy barrel is said to be an inclined plane. So let me give you an illustration of what is an inclined plane. All right, so alright, so this is an inclined plane. Okay, now here we are giving an angle theta to be what? 30 degrees, because a barrel is very what? Heavy. So for us to be able to carry it up to a plane, for us to be able to carry it to a floor of a lorry, we are going to use what? A plane, and that plane is what we say to be an inclined what? Plane, right? Okay, so this is the distance moved by the effort, while this is the distance moved by what? By the load. And we still remember that the velocity ratio is equals to the distance moved by effort over distance moved by what? Load. Is that clear? And we also remember that velocity ratio is equals to 1 over sine what? Theta. Now from this question, we are given the angle to be 30 degrees. So we are going to use the velocity ratio equals 1 over sine theta. And let's go. Velocity ratio is equals to 1 over sine, my sine theta is 30. Okay, I will say sine 30, which is equals to 1 over, what is sine 30? Sine 30 is 0.5 or 1 over 2. Okay, I can say 1 divided by what? 2, right? Then by the time we say 1 divided by 1 over 2, which is the same thing as 1 over 1 multiplied by 2 over 1. Then by the time we multiply, our answer is equals to 2. Now from what we got, the correct option to this question is option D. Alright, I hope that is clear. Let's look at the next one. The efficiency of a machine is 70%. Calculate the work done using this machine to move a load of 140 kg through a vertical height of 2.0 meters. And we are giving G to be 10 meters per second square. So let me go again. The efficiency of a machine is 70%. Okay, now calculate the work done using this machine to move a load of 140 kg through a vertical height of 2.0 meters. And we are giving G, which is acceleration due to gravity, as 10 meters per second square. Alright, so the options we have in the question, the option A is 4,000 joules, option B is 3,000 joules, option C is 1,500 joules, and option D is 1,000 joules. Now, the first thing that will come to your mind if you want to answer this question is this. They say calculate the work done. Now, the person that is using this machine is actually doing what? Work. So we are going to be solving this problem with the efficiency and work done formula. So let's go. Efficiency is equals to work output divided by work input multiply by 100%. Okay, now this work output, let me break it down, is equal to load multiplied by distance moved by load all over because you are looking for the work input, the work done by the person using this machine. All right, you're going to say that we are looking for work input, then multiply by 100%. Okay, now from this question we are given the load of 140 kilogram. Now this 140 kilogram is the mass of the load, not the load itself, because the load is a force and effort is a force. So let's get the load by saying that our load is equals to what? Mg, right? Okay, then we have 140 multiplied by 10 is going to give me 1500 Newton. Is that clear? So that is just our load. We are going to impute it in and solve. Then the distance moved by the load is given as 2.0 meters. Okay, so let's solve. Using the formula, we have that our efficiency is given by 70 over 1. Then it is equals to, our load now is 1500. 1500 multiplied by the distance moved by load is given as what? 2 meters, right? So write what? 2, okay, divided by, you're looking for work input, so this is work input. Now multiply by 100%, or I can say multiply by 100 over what? 1. Is that clear? So let's multiply all through to see what we have. Now this is, let me say 70 is equals to 1400 multiplied by what? 2 multiplied by 100 divided by what? Work input. Now since I am looking for the work input, I'm going to make it the subject by saying, okay, by saying 70 over 1 cross multiply. The work input is equals to 1400 multiplied by 2 multiplied by 100, right? Then divided by 70. Okay, so let's cancel out. 0 cancel itself 1, cancel this 1. Okay, 7 cancel itself 1, then it's going to give me what? 2, right? Now we have 20 multiplied by 2 multiplied by 100. Okay, so we have the work input is equals to, let me say 20 multiplied by 2 then multiply by 100. By the time you multiply it out, you're going to get your answer to be 4000 what? Joules. Is that clear? Now if you are given a question under work done by a person using a particular machine, the formula you are going to use is the work done formula. Is that clear? So from what we have, the answer to this question, the correct option is option A. I hope that is clear. Alright, let's look at this question. What effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? Let's go again. What effort will a machine of efficiency 90% apply to lift a load of 180 Newton if its effort arm is twice as long as its load arm? So we have option A, 80 Newton, option B, 90 Newton, option C, 100 Newton, and option D, 120 Newton. So let's look at this to see what we are going to do in getting the answer. So we are looking for effort. So the first thing we are going to do, let's state our parameters given and get all things stated so we can get our efforts. All right, my efficiency is given as 90%. Okay, we are looking for the effort. All right, so we're given a load of 180 Newton. Okay, now for us to get our velocity ratio is equals to what? The distance moved by effort to the distance moved by load. Now I will say distance moved by effort to the distance moved by load. But in this question, the effort arm is twice as long as the load. So if the distance moved by the load is L, all right, that means that the distance moved by effort is what? 2L. Simply, that is what they mean. Is that clear? All right, so let's do the division. We have velocity ratio is equals to, my distance moved by effort is what? 2L. Why that moved by the load is L. When this cancels out, my velocity ratio is equals to 2. Is that clear? So what we are going to do now is to apply our efficiency formula to solve. Now, let's go. We have the efficiency is equals to mechanical advantage over velocity ratio multiplied by 100%, right? Let's just substitute into what I have. Because I'm looking for the effort, I'm going to first find my mechanical advantage. Now my efficiency is 90. 90 over 1 is equals to mechanical advantage over velocity ratio is 2. Now this is over 2 multiplied by 100 over 1, right? So the next I'm going to do is to say 90 over 1 is equals to 100 multiplied by MA, that is 100 MA, alright? And divided by what? By 2. Let's cross multiply. We cross multiply to get 100 MA is equals to 180, right? So let's divide both sides by 100. We divide both sides by 100. Okay. Now, my MA will be equals to 1.8. Alright, so let's go. I will say my MA is equals to 1.8, right? Now, the same MA is also equals to load to the effort. Now, I will say that MA is equals to the load over what? Effort, right? Now, let's go. What do we have? We're going to say that my 1.8 is equals to, what's my load? My load is what? 180 Newton. So this is 180 Newton over what? My effort, right? I'm simply going to say cross multiply. So this is cross multiply. Now, what do we have? We're going to say that effort is equals to 180 over 1.8. Is that clear? And by the time you divide, my answer is going to give me what? 100 Newton. Is that clear? So the correct option in the question provided is option what? C. So most times if you are given a question this way, you are going to relate it that way. How do I mean? They gave us the arm's length, the effort length, and the load length. So we have to relate it to get the velocity what? Ratio. Is that clear? A wheel and axle is used to raise a load of 500 Newton by the application of an effort of 250 Newton. If the radii of the wheel and axle are 0.4 centimeter and 0.1 centimeter respectively, the efficiency of the machine is what? And we are given the options A to be 60 degrees, option B to be 50 degrees, option C to be 40 degrees, and option D to be what? 20 degrees. And the first thing that will come to our mind is this, is stating the parameters given, then we can be able to solve for the efficiency. Alright, so let's go. Our load L is giving us 500 Newton. Okay, then by the application of effort, E is giving us 250 Newton, right? Okay, now if the radii of the wheel and axle, remember for a wheel and axle machine, the velocity ratio is equals to the radius of the wheel over radius of what? The axle. Alright, but from the question we are given that the radius of the wheel is what? Is 0.4 divided by 0.1. Okay, so by the time you divide, you're going to get the velocity ratio to be what? 4. Now let's solve for the mechanical advantage. MA is equal to load over effort. So what's my load? My load is given as 500 and my effort is given as 250. So we're going to say 500 divided by 250. So what do we have? We're going to have what? 2. Now, with that being said, let's move into the efficiency formula. Efficiency E, F is equals to MA over VR times 100 over 1. Because it is expressed as a percentage, you can say multiply by 100%. Okay, now efficiency is equals to, what's my mechanical advantage? I got it as 2, so this is 2 over, my velocity ratio is what? 4, so this is over 4 multiplied by 100%, right? Now if 2 should divide itself 1, divide, I'm going to have what? 2. Now this is the same thing as 0.5. Then efficiency is equals to 0.5 multiplied by 100%. By the time you multiply, the answer is going to give our efficiency to be 50%. Is that clear? Now from what we have in the option, the correct option to this question is option what? B. I hope that is clear. If this video was able to help someone, subscribe to this channel, comment and share so that students that are writing the forthcoming JAMB 2025 be able to understand problems associated with machine. And turn on the notification button to get notified each time I send videos. I'll see you next time in the next one. Bye for now.